Time is 8:56. Shall we continue that? So in the previous class, we have discussed many of the things related to reed-Solomon code. So encoding of reed-Solomon code we have completed. Let me quickly refresh what reed-Solomon code is, and then we will come to decoding part. So in reed-Solomon code is basically NK coding scheme. Block length is n symbols, n symbols are there, and k symbols are information symbols, and means remaining n minus k symbols are the redundant symbols. So this reed-Solomon code scheme can correct up to n minus k by 2 number of symbols. The number of bits corrupted may be any, but only up to n minus k by 2 number of symbols can be corrected. So it means in one particular symbol there may be many errors, many bits have got corrupted. This may also be possible. So this is data information, and these are the redundant symbols, or you can call it parity symbols also. So if these are 2T symbols, then T errors can be corrected. Total size is n symbols. So we have discussed about the encoding scheme. For encoding, one polynomial is required, that is we are calling it gx. The degree of this polynomial is 2t basically, and it is a product of these 2t factors. One of the factors is x plus alpha square, and so on, where alpha is one of the primitive root of the Galois field gf 2 to the power n. So this is product of these factors. And suppose the message polynomial be m0, m1, mk minus 1. It means these are the message symbols. M0 is one of the symbol, M1 is another symbol, Mk minus 1 is the kth symbol. All of these are the elements of this field Gf 2 to the power n of message encoded at the block representing polynomial. So this is the polynomial corresponding to this these symbols. So that's why we are calling this as the message polynomial. And the transmitted polynomial is x. How can you find out? First, find out the value of SRx, that is equal to px into x to the power 2t mod of gx, and then Sx is equal to this px into x to the power 2t minus this. This is, you can call it the remainder actually. So SRx. The point here is that if you divide Sx by gx, find out the remainder, it will be 0. If everything is correct. Otherwise, it will not be 0. So you can easily check that it has got corrected or not through transmission. The only the way is divide this by Sx, whatever you have received, by gx, and find out the remainder. If the remainder is 0, it means it is not corrected, and if the remainder is not equal to 0, it means it is corrected. So now in Reed-Solomon decoding, Sander has sent S6 that is equal to QX into GX. Because I already told S6 is completely divisible by GX. So S6 can be written as a factor, that is QX into GX, and sends over the coefficients of S6. So receiver suppose has received RX. Instead of S6, suppose receiver has received RX. If they are equal, it means this Rx has to be divisible by Gx. So there will not be any remainder if we divide Rx by Gx. Otherwise, there will be some value, means the remainder will not be equal to 0. And suppose that is equal to Ex. So Rx is equal to Sx plus Ex, because Sx is already divisible by Gx and this is the remainder. Whatever you have received, that is Rx. So Rx is equal to S6 plus Ex. So Ex is error polynomial. So receiver knows Gx and its roots. Receiver can evaluate Rx at every root to obtain a system of equations to determine which coefficients of Rx are in error and the value of the error. So our aim here is to find out the where error has occurred, in which symbol error has occurred, and what is the value of that, how the error can be removed also. So there may be multiple symbol error, means in one particular symbol there may be multiple errors also. So for that, the requirement will be to find out the syndromes basically. Syndrome is what? Whatever has been received, that is Rx. Divide Rx by each of this factor of the polynomial Gx. Gx is equal to x plus alpha into x plus alpha square into x plus alpha power 3 and so on. So divide Rx by each of the factor, that is x plus alpha to the power j, where j is varying from 1 to 2t or n minus k. So Sj is the remainder, that is called the syndrome, after dividing Rx by x plus alpha power j. The remainder Sj are known as syndromes. So Sj is equal to Qjx into x plus alpha power j plus Rx. So x is equal to alpha to the power j. Sj is equal to R of alpha to the power j. This is the value of the syndrome, Sj. Is equal to, otherwise, R of alpha to the power j. If there is no error, in that case, its value will be equal to 0. Because if Gx divides Rx, it means every factor of Gx will also divide Rx. So if it does not divide, if Gx does not divide Rx completely, it means at least one of the factor of Gx, maybe x plus alpha or x plus alpha square or any of the factor, will definitely not divide the polynomial whatever has been received. So we are finding that actually. So Sj is equal to R of alpha to the power j. You can find the value of this value polynomial Rx for each value of the root of that polynomial Gx. It is equal to S of alpha to the power j plus, because Rx is equal to Sx plus Ex. So that's why Sj is equal to R alpha to the power j is equal to S alpha to the power j. I think it will better. Yeah, sorry. Actually, I got some problem. I have to go somewhere. I got one message. So we will continue in the next class, right? I have some urgent meeting now. They are calling me. Okay, sorry. We will continue this at this moment of time. I'm stopping here.
Okay, thank you, sir.
Okay?
Thank you.
Yeah, sorry.